Okay, so good afternoon to all and welcome to lecture number 5. Today, in this lecture, we'll be talking about one-to-one difference between human vision system and computer vision system. So before that one, we'll study what is meant by low-level vision system, what is by mid-level vision system, what is by high-level vision system. And then we'll see the difference between low-level vision system and high-level vision system, and then how high-level vision system is achieved. And after that, we'll see the one-to-one difference between human vision system and computer vision system. And at the end of this lecture, we will study what is the difference between computer vision and machine vision, how they are different. And then at the end, we will see what is by one-dimensional vision system and what is by two-dimensional machine vision system. So we'll see the difference, how one-dimensional machine vision system is done and how two-dimensional vision system is done. And then we'll see the one-to-one difference between one-dimensional vision system, machine vision system, and two-dimensional machine vision system. So that is our today's agenda. So let me just recap our yesterday's lecture in one or two slides, and then we'll continue our this one. So yesterday I talked about how basically computer sees the external world, in the form of binary image or in the form of grayscale image or in the form of color image and so on. And also we talked about how many shades will be there in the binary image. First thing is that number of bits used for binary image will be equal to 1. Number of bits used for grayscale image for representing each pixel will be equal to 8-bit, that is nothing but the 1 byte of memory. And number of bits used for color image will be equal to 24 bits. Since in color image there are 3 planes, R plane, Z plane, and B plane, and every plane, each pixel in every plane is represented by 8-bit, that is nothing but the 1 byte of memory. And so in total, 1 pixel in 3 planes will be represented by 24 bits. Then we talked about the number of shades. So number of shades equal to number of 2 raised to number of bits. So in case of binary image, since number of bits used are 1, so 2 raised to 1 equal to 2 shades are there, that is nothing but the black and white. Whereas in case of grayscale image, number of shades are basically number of bits are used for representing every pixel is equal to 8-bit or 1 byte. So 2 raised to 8 is equal to 256 gray shades are there. So ranging from black to white. So there are several shades. So 0 is considered as a black and 255 is considered as a white. So in between 0 to 255, there are several shades available. And in case of color image, we are using 24 bits to represent the color image. So number of shades will be equal to 2 raised to 24, and that is equal to 616,777,216. That is more than 16 million color shades are there in case of color. And also after that, we have studied how much memory is needed for storing the binary image. If same size of binary image is there, grayscale image is there, and color image is there, how much memory is needed for binary image, then how much memory is needed for color image, and then grayscale image. So for storing the binary image, you need m by n bits. For storing the grayscale image, you need m by n bytes. And for storing the color image of same size, you will need m by n multiplied by 3 bytes. So more memory is needed for color image and very less memory is needed for binary image. So that is what we have studied in yesterday's talk. Now, first we'll study what is meant by low-level vision, what is meant by mid-level vision, and what is meant by high-level vision. So the computer vision processes are like, for example, there are 3 different types of computerized processes. One is a low-level process. So in low-level vision, so generally what is there in low-level vision, or it is also called as the early vision. Okay, so your input is image, your output is also image. So you are processing that image in between. So now what you are doing exactly here? See, in your input is bad quality image, your output is good quality image. So you are processing that one. Basically, you are making bad quality image into the good quality image. Like for example, if you have taken a photograph in the dark room, So if you take the photograph in the dark room, it will be totally black and most of the objects are not visible. So by using enhancement technique, means you have given an input as a dark image, and then by using enhancement algorithm, you are processing that dark image and you are making a quality of that image as a good one, which is very clear, where all the objects are seen clearly. Or for example, your input is corrupted by noise, means a lot of noise is there, and you'd like to remove that one. So by using filtering, so this is the process, filtering process, you are removing the noise and then you're getting the good quality image. Means here your input is bad quality image, you're processing it, and finally you are getting the good quality image. So input is image, output is also image in case of low level processing. So you are operating on the pixels in the case of low level image processing or low level computer vision, and or it is also called as early computer vision. So here your input is image and output is also image. Then in mid level process, okay, what we are doing in mid level computer vision, we are trying to extract the features from the objects. You know that features are generally used for recognizing the object or classifying the object or predicting the events and so on. So here your input is image, you are processing that one, you are extracting the good set of features or descriptors from that image or object, and then those features are used for recognition purpose or prediction purpose, so like that way. So what is the input? Input is your image or object, and then from that one, what you are doing, you are extracting the features from that one. So your output is feature, input is image. So this kind of process is called as the mid-level process. Whereas in the case of high-level image, high-level computer vision, you are making the sense of that input. Means you have the sequence of the input, sequence of images are there as an input. You are processing that one. So that processing, see, earlier you might have done that one low level processing, then mid level processing. Now next one is that you'd like to make the sense out of that one. So you'd like to describe the scene or something like that. So or you'd like to interpret that image. So your output will be the interpretation of the sequence of the image. So your input is sequence of images and output is interpretation of the image and so on. So this is the high level image or high level computer vision and so on. So particularly this low level processing and mid level processing is generally covered under the image processing subject, and whereas half part of mid level image processing and completely entirely high level processing is covered under the computer vision. So I hope that this is very clear to you what we are going to cover in the computer vision and what you have studied in the image processing subject. Now, there are four different areas generally which are very close to each other, and people get confused between those four areas. Means what is exactly the difference between those four areas? So first one is basically a digital image processing. What is by digital image processing? So yeah, as I told you that in the digital image processing, your input is image, you are processing that image, and you are getting the output as an image. Only thing is that input is bad quality image and your output is good quality image. Means your input and output both are images, right? Now, whereas in pattern recognition, what is there? In a pattern recognition, your input is image. Like for example, this is your input, okay, and then your processing will do, and it will identify. Like for example, this is a mobile class. Okay, so again, for example, if I show this as an image to the system, your system will identify it as a pen or something like that. So your input is image and output is basically class. Like for example, this object belongs to class 1, this object belongs to class 2, and so on. So here input is basically a image and output are nothing but the classes. So that is nothing but the pattern recognition. You are recognizing the patterns. Okay, whereas computer graphics, here you are giving the set of descriptor as an input. You are processing those set of descriptor, and you are making the synthetically generated image, means artificial image you are making from that one. So in computer graphics, what is that? Input is basically set of descriptors. You are processing that one, and then you are making the synthetically or artificially generated image. So your output is image, but your input is set of descriptor. So that is nothing but your computer graphics. And then finally, the computer vision. In case of computer vision, basically your input is the sequence of images, and you are trying to understand the image, you are trying to recognize the different object, you are trying to interpret the image, or you are trying to describe the image. So that will be your output, whereas the input is just sequence of images. So I think you got the clear idea what is the difference between image processing, pattern recognition, computer vision, and computer graphics. And also, you know that there is also one area which comes under the machine learning. This one under the artificial intelligence, that is nothing but the machine learning. So in machine learning and computer vision, so basically computer vision is early vision processing part, and then machine learning is the latter part to learn the things from whatever is the output from the vision system. So from that one, it will try to learn, and then it will try to recognize the things and so on. So this is all about the four different areas which are overlapping to each other in this field. Now we'll see what is mean what one-to-one difference between low-level method, low-level computer vision method, and high-level computer vision method. So as I told you that in a low-level computer vision method, you are processing on the pixel level. Okay, so here first difference is that it usually use very little knowledge about the content of the image. So that is not known. So you are considering the small portion of the image, you are processing that pixel by pixel, and then you are getting the output. So you are using here very little knowledge about the content of the image. But in the case of high level image processing, okay, it is based on the knowledge goals and plans of how to achieve those goals and so on. So this kind of things are not there in low level vision. So low level vision is basically a early vision where you are making this pattern or object which is suitable for the high level image processing or high level computer vision and so on. Then second difference between the low level computer vision method and high level computer vision method is that in case of low level computer vision method, we don't use artificial intelligence methods for processing or inferring and something like that. But in case of high level computer vision method, AI methods are widely applicable, like searching, sorting, or recognition and inferencing and so on. So there are several methods of AI technique which are highly applicable okay, in the high level computer vision. Whereas here you are just doing the processing on the pixel level, so you don't need any AI methods for processing the things. Then third difference between the low level computer vision and high level computer vision is that these methods completely overlap with digital image processing. DIP means digital image processing. So most of the low level computer vision methods are completely overlapping with DIP, whereas high level computer vision method does not overlap with DIP methods, because here your input is some image but your output is something different or meaningful information and so on. So it does not overlap with the DIP methods. And then what is the fourth difference? Fourth difference in a case of this one, low level computer vision method and high level computer vision method is that what kind of data is used as an input in case of low level vision method. Just 1 minute. Okay, so generally data used in low level computer vision methods are the intensity values of pixels from the original image. So you are playing with only intensity values of pixels from the original image. So the data which is used in low level computer vision method is intensity values of pixels. Whereas in case of high level computer vision method, what kind of data you are using? You are using the high level data like the object size or shape or mutual relation which are used by using like as a graphical technique. And then usually this symbolic representation of data is used in case of high-level computer vision method, whereas only intensity values are used for processing the low-level computer vision method. So data which is used in low level is totally different as compared to data which is used in high-level computer vision method. Then the next difference between the low-level computer vision method and the high-level computer vision method is that priori information is not at all needed in case of low-level computer vision, whereas priori information is always useful in achieving the goals in the high-level computer vision method. Okay, priori information is always useful in the high-level computer vision method, whereas this is not at all required in case of low-level computer vision method. Then sixth difference between the low-level computer vision method and high-level computer vision method is that proportional representation is not important. Okay, or fuzzy logic is also not basically used in low-level computer vision. So whereas proportional representation is important in case of achieving the high-level computer vision method or achieving the goals in the high-level computer vision method, then you know that I don't think that you have studied this fuzzy logic or this one. Generally, inference techniques are used in the fuzzy logic. So this is not at all used in the low-level computer vision method. So inference techniques are not used for processing the low-level computer vision method, whereas for achieving the goal, in some of the techniques, inference techniques are also used for achieving the goals. So these are the 7 differences between the low-level computer vision method and the high-level computer vision method. I hope that this is clear to you. So just summarize that here, you don't need a priori knowledge, or basically here you don't need knowledge about the content of the image, but here knowledge about the image is important, or project is important, like for example goals and plans of how to achieve these goals and so on. AI methods are not used in this low level, whereas AI methods are widely applicable. Here it completely overlaps with DIP, and in high level it does not overlap with DIP method, whereas the input data on which processing is done, it is just intensity values of pixels of the original image, whereas here the data which is used in high level computer vision is the object size, shape, or relation between those different objects, mutual relation between them, and so on. So usually symbolic representation of data is used in case of high level, and then priori knowledge is not at all required in case of low level, whereas priori knowledge is highly useful in high level computer vision. Similarly, proportional representation is not important in this, whereas it is important in case of high level computer vision. And inference techniques, like which are used in fuzzy logic, are not used in low level computer vision, whereas inference techniques are widely used in high level computer vision. So this is one-to-one difference between the low level computer vision and high level computer vision. Now we'll see how high level computer vision is obtained. So as I told you that generally it is we start with some form of the real model of real world, with means for example with goal, like would like to achieve this one and so on. So we start with the in case of high level computer vision, we begin with the some form of a forward model of the world. Okay, now after that we compare that one with the model with a reality perceived in the form of digital image. See that yesterday we have seen that a block diagram of computer vision. So first step is basically your image processing, and that is nothing but the early computer vision. And then after that you have this a model which is basically mathematical model, which is developed for achieving the real world objective. And then this mathematical model, whether it is achieving the real world objective or not, so that is compared And if there is basically difference, then you have to modify your mathematical model. And again, you have to go back to the image processing early vision system, and then you have to make the correction. You have to update the things, and then again you have to come back with the modified model. And this model should fit the actual world of reality. So if there is difference between the proposed model and the actual world model, then this difference we have to minimize it. So this difference should be, ideally it should be zero. Okay, if that it is not zero, then we have to update the model using the low level image processing. And then once this difference between the model and the actual real world model, the proposed model and actual real world model, if this difference is zero, okay, then you'll get the completely output, means basically the desired output, and so on. Otherwise, what you have to do, you have to modify the model and then repeat this 1 to 4 steps. These are first step, second step, third step, and fourth step, till you understand scene fully. Means your understanding of scene or your goal should be matched with the proposed model. And if there is difference, this difference you have to minimize it by updating the model. So in that way, in a high level computer vision, what we do, we start with some form of model, which a mathematical model of real world. Now this is mathematical model and this is the real world, and then we are trying to match this mathematical model with the real world. Initially this will not be perfectly matching, so there may be difference, so we have to minimize that difference. Now we have to go back to the early vision system, and again we have to modify the things, we have to modify the model, and then again we have to compare again. If there is difference, we have to modify it. So how long we have to do? Unless and until we get the difference of the proposed model and the actual things which is matching. And then if it is matching, then we have to stop, and then we can use that one for the required action, and so on. So begin with some form of the model of the real world, compare the model with reality perceived in the form of digitized image. Then after that, if difference is not zero, then update the model using the low level image processing, modify the image model, and then last step is that you have to repeat this one until you get that your scene is completely understood by your model, and so on. So these are the various steps involved in the high level computer vision. And now after that, we'll see one-to-one difference between the human vision system and the computer vision system. Okay, so you know that for a human being, how many eyes are there? We have 2 eyes, right? And then our eyes are positioned such that we get the view of what is the field of view angle. So for our eyes, human eyes, it is 220 degrees field of view, right? But in a case of computer vision, what is the analogous with this one eye for the computer? Analogous with eye is nothing but your camera. Now cameras can be, it's not like that, okay, you can fix only one camera, you can fix many cameras. So you can have the 360-degree field of view in a case of computer vision system. So you can see from the front, you can see from the back, you can see from the side, left, right, and so on. So there is no concept of backhand of front or something like that. You can have as many eyes or as many cameras with you in a computer vision system, but for a human being, there are only 2 eyes or 2 cameras, I'll say that. Okay, and the field of view means we can see up to only 220-degree field of view, right? We cannot see what is happening back of our head or back of us. We can see only up to 220 degrees Celsius, 220 degree or something like that. But in computer vision system, we can see the complete 360-degree information. That is the first difference between the human vision system and the computer vision system. Second difference is that, okay, human vision systems are best at seeing varies across the field of view. Okay, So for instance, humans tend to see color better at the center of the visual field. Conversely, we can detect low light objects better at the periphery. Now, what is the meaning of this one? You know that in very first lecture, I told you the structure of our human vision system. So in the retina, there are two types of sensors. Okay, so which are those? One is the rod, and another one is the cone. And cone is basically concentration of cone is mainly at the center of the retina. That is nothing but the foveal area, and cones are responsible for color perception, whereas rods are not there, or concentration of rod is very less in the central part of the retina, that is foveal area, but it is more at the outside. So these rods are responsible for detecting or seeing the objects in the dim light. So that's why here we can see the color at the center very clearly. See, human vision systems are best at seeing various varies across the field of view. For instance, humans tend to see the color better at the center of the visual field. Why? Why at the center? Because your foveal region will be directed to the center of that one, and in that foveal region there are a lot of concentration of cones, and because of the cones we can see the color better at the center of this one. Whereas at the periphery of your this one retina, a lot of high density rods are there, and these high density rods will detect the low light objects better in the periphery. Okay, whereas in case of computer vision, I told you that there is no concept or rods or cones or like that. There is only three sensors are there, that is RGBs, color sensors are there. We can say that these are the cones in case of computer vision. And it's not like that it is concentrated only on the center part, or it is not less is there at the periphery or something like that. In a computer vision system, this concentration is uniform, okay, across all the part, across all the part of the field of view. So, and you know that field of view of computer vision system may be 360-degree, whereas the field of view of human vision system is only 220-degree. Means what we can conclude from the second difference is that we can see, as a human being, we can see more accurate color in the central part of our vision system, and we can see the peripheral low light object we can detect at the periphery. But here, in case of computer vision system, since all the cones, means basically red channel and green channel and then blue, they are equally distributed in entire field of view. So there is no concept of good vision at the center or bad vision at the periphery or something. That everywhere you will see the same kind of thing. So that is the second difference between the human vision and the computer vision. Then the third difference in the human vision and computer vision is that there are, see, as I told you that in case of human vision system, there are two types of light sensor. One is rod and another one is cone. So there are two types of light sensors in the human visual system, and sensor cells on the human retina break down into the rods and cones. Whereas in case of computer vision, we don't have this specialization. Like for example, we don't have rods or like that. It doesn't have concept of rods and cones. It has only three types of color sensors, which are those: red color sensor, green color sensor, and blue color sensors. So there is no concept of rods and cones in case of computer vision, but in case of human vision, there is a concept of, or basically there are two types of sensor, whereas here only one type of sensor is there, and that is nothing but the cones. I'll say these three color sensors as a cone, like that. So that is the third difference between the human vision system and the computer vision system. Now the fourth difference, okay, how information is passed from retina to the brain in case of human vision system, and then how information is passed from this in the computer vision. So let's talk about this one, human vision system. So as I told you that these photocells, like for example this one, cones and rods are responsible for converting the light into the this one electrical signal, and then it will be basically passed to the brain through the chain of chemical events involving sodium and potassium ions. So this kind of events are happening. In case of chemical events are happening, this chain is there of chemical events involving sodium and potassium to pass the information, to pass the signal from the retina towards the brain and so on. But here, in a case of computer vision signal, it is transmitted through the electrical impulses. Hence, CV is faster than human vision system. Computer vision system is faster than human vision system comparatively. Okay, because here electric impulses are used, whereas chemical events involving chain of chemical events involving sodium and potassium ions, okay, they pass the information from retina to the brain. So that is the fourth difference between human vision system and the computer vision system. The fifth difference between the human vision system and computer vision system is that in a human vision system, the first stage of interpretation take place at the retina. Okay, like for example, color detection and age detection happens in the ganglion cell of the retina. Okay, means we are doing the recognition, like as a mid-level image processing can be done in the retina itself of human vision system. But see, in a case of computer vision, okay, when you are capturing the images with the help of camera, the role of camera is just to capture the images. It will not process, like for example, whether what kind of color is there or what kind of edges are present in that one. So there is no vision system involved in the computer vision system. Like as in computer vision, the sensors which capture the light don't do any kind of interpretation. But here, the sensors which are capturing, so what is the sensor which is capturing the real world? That is nothing but our eye. So in the eye level itself, we are trying to interpret what kind of things, color and edges, where it happens in the ganglion cell of the retina. But here, this kind of thing is not happening. It will be sent to the processor, and then you have to develop an algorithm to detect that one. So first vision system, okay, in human vision system, at the first stage, interpretation takes place at the sensor level itself, but this is not happen. This does not happen in case of computer vision. So that is our fifth difference between the human vision system and the computer vision system. Then sixth difference is that, like, okay, so for example, you have created the image such that 256 by 256 grayscale image is there, and then assume that your first column is having intensity only 0, 0, 0, 0 intensity. Then second column is having intensity 1, 1, 1. Third column is 2, 2, 2. So like that way, 256th column will be having intensity equal to 255. Now, when you visualize this image on the computer screen, you will look like that left side is dark black, and then this intensity is increased, and the right side is white. Now, when you take any two consecutive pixels, and as a human being, will you be able to identify what is the difference in the shade? So it is very difficult. So out of 256, okay, if you make the channel or beans like as a 32 beans, at the most 32 or 24 or 32 beans, then we'll be able to make the difference between this gray level and this another gray level or something like that. So we cannot, as a human being, we cannot distinguish all the shades, nearby shades with our human eyes. We have to hardly we can distinguish a couple of gray level shades, or at the most 32 gray levels and something. That is what research says. But whereas in the computer vision, if you distinguish, okay, if you make it so it is possible to distinguish between what is the shade of this pixel and what is the shade of this pixel. So our computer vision system can distinguish all those 256 gray shades. So distinguishing ability of computer vision is better as compared to the human vision system. That is the advantage of computer vision over the human vision system. So this is one advantage. Then second thing is that in case of color, as I told you that suppose for example you have obtained the color image with RGB channel, and then each channel is is encoded with 8 bit. Like for example, 8 bits are used for R channel, then 8 bits are used for green channel, and then 8 bits. So in total 24 bits are there. So total number of shades will be equal to 2 raised to 24, that is 16 million. More than 16 million color shades are there. But can we, as a human being, can we distinguish all those color shades with our eyes? No. Research says that hardly we can distinguish out of these 16 million color shades, hardly we can distinguish only 900 to 1000 color shades. So that is possible. That is the limitation of human vision system. Whereas in the computer vision system, all those more than 16 million color shades which are there, every color shade can be distinguished by using the computer vision system. So distinguishing ability of a computer vision system in case of grayscale or in case of color is higher as compared to the human vision system. So these are the differences between the human vision system and computer vision system. The next difference is that, okay, there are some limitations of biological vision or human vision. So for example, in terms of scale or speed or physical and mental, all those things, if you consider conditions, then there will be a biasing, or there will be basically we get tired, or we can't do that much of amount of work and so on. So that kind of things like for example, if you use the human vision system for recognizing the rocks of the oil in the oil industries, so how many rock images we can recognize or basically examine in a one day or like that? Hardly 200, 300, 400. But with the help of computer vision system, we can do that one up to 50,000, 1 lakh and something like that. So scale of work in the computer vision will be higher as compared to the scale of work in the human vision system. Also, speed will be less in case of human vision system, whereas the speed is also higher in the computer vision system. And then we have a limited memory, whereas memory can be expanded in case of computer vision, and then time required will be more in case of biological or human vision system to process that one, whereas time required in case of computer vision will be less. So these are basically biological limitations are there in case of human vision system, but there is no boundary in case of computer vision system. So at any scale we can use, at with any maximum speed we can do the work, and size of the image or anything memory requirement will be also will not be a boundary in case of computer vision system. Then another see, these are the disadvantage of human vision system, but it's not like that everywhere human vision system is bad. So sometimes human vision system is good as compared to the computer vision system. After all, computer vision system is designed by the human being itself. So we cannot basically mimic each and everything of human into the computer. It requires time to do all those things, because you need to understand mathematically correct model, and then you can deploy in a computer. So for example, in a case of human attributes like as a subjectivity or behavior, missing common sense or knowledge level or context or bias, ambiguity, all those things are there as a human attributes in a case of human vision system, whereas these things are not there in a case of computer vision system. But in computer vision system, there is a technology advancement which deals with the complexities or very high precision, accuracy, transparency, and objectivity and consistency will be there in this case. Whereas in case of human vision system, human attributes are there, like as a subjectivity is there, behavioral factors are there, missing common sense is also there, or knowledge level is also different. Then context of that scene will be also different, so which can be easily understood by the human being, so which cannot be understood by the computer vision system, and so on. There may be bias, ambiguity, and so on. Whereas, the next difference between the human vision system and computer vision system is that it gives the abstract or generalizable, contextual, and intuitive, whereas it lacks the abstraction or abstract meaning and concept in case of computer vision. Here in human vision system, natural intelligence or creativity or broad focus is there, whereas there is no natural intelligence in the computer vision. We have to do the programming, we have to train the computer according to this one. So focus will be narrow. Here in a human vision system, focus will be broad. So all those 8 element differences are there in a case of human vision system and the computer vision system. And the last part of this one, just 1 minute. Last part of this one lecture is the computer vision versus machine vision. So what is the difference between the computer vision and machine vision? So machine vision is often thought to be one in the same with the computer vision. However, there are really two different terms. These are really two different terms for overlapping technologies. So in computer vision, basically, which generally refers to the automatic extraction of the information from the digital image data with an emphasis on the image analysis function across a wide range of theoretical and practical application. Okay, means basically what we are doing, we are trying to understand the images, we are extracting the features, we are theoretical as well as practical in case of computer vision. Whereas machine vision, generally this vision system is used in industry. Okay, so traditionally refer to the use of computer vision in an industrial or practical application or processes, and the machine vision systems uses software to identify the pre-programmed features and is frequently used to trigger a variety of set actions based on the findings. So particularly the vision system which is used in industry is called as the machine vision system with some goals or something like that. So advances in machine vision technology have led to the development of vision sensors or smart cameras or vision controllers or embedded industrial PC platforms as alternative choices for the machine vision systems designers are there, and so on. So the main difference between the computer vision system and machine vision system is that these machine vision systems are generally used in industry, whereas these are used for general purpose and so on. Right now, look at this one-dimensional vision system and the two-dimensional vision system. So in one-dimensional system, see that this vision, and this vision is captured line by line. Okay, so by just scanning line by line of this, this is the object which is under observation, and then it will be scanned with line by line, and then this difference variance is obtained between line to line, and then defect can be found in this one division system. Means we instead of considering the entire image, we are considering only one line at a time, whereas in the case of two-dimensional vision system, we are considering the entire image at that time, and then we are capturing the image, so whole image is considered, whereas in this case only one line is considered. Here entire image, like for example, this is the conveyor belt, and then this is the product, and then you are capturing the image of that one, and then you are doing the processing of this one. So here, suppose for example, this is the conveyor belt, this is your product, and then this is your vision system, so it will be scanned line by line, so like as a one-dimensional thing. So here entire image in two-dimensional is captured, so instead of entire image, one-dimensional, one line by line scanning is done. Now the main difference between the one-dimensional vision system and two-dimensional vision system is that 1D vision system analyze the digital signal one line at a time instead of looking at an entire picture. Whereas in case of two-dimensional system, the complete picture of that object or that product is taken, and then processing will be done. Okay. Whereas this one-dimensional vision system generally look for the variance between the previous line and the and following acquired lines, and then from that difference we can infer the knowledge, or basically whether there is any defect or like that. Whereas in a case of two-dimensional vision system, we can use different types of different resolution camera, like as a 10 megapixel camera or 20 megapixel camera or 30 megapixel camera and above. And these are becoming a part of standard 2D product lineups. So how the speed, cost, and related topics differentiate the available resolution. Whereas where we can use this 1D vision system, particularly for detecting the faults or defects in the material manufactured in a continuous process. Like for example, paper manufacturing company is there, so it is manufacturing the paper, or metal manufacturing company is there. So you need a basically uniform quality for entire sheets or plastics, or even this one in textile industries when you are manufacturing the clothes. So everywhere the quality should be same. So this is checked line by line, and then if there is defect, immediately it will be corrected or basically checked, detected, and then you can control the quality of the product and so on. So basically 1D system is used where the material is manufactured in a continuous process, such as paper, metals, plastics, or clothes, or in textile industries, non-woven, and so on. Whereas for product inspection or something like that, individual product inspection, this 2D vision system is used for individual product inspection and so on. So I think you got the difference between the one-dimensional vision system and two-dimensional machine vision system, where it is used and so on. So we'll stop here. Thank you very much. And in tomorrow's lecture, we'll see the next part, that is the application of computer vision. So thank you all. So I'll just stop the recording.